How's it going, YouTube? This is your boy Isma coming back to you with another Try Hack Me project. And today I am working on Intro to LAN, and we are going to be learning about some of the technologies and designs that power private networks. So without further ado, let's do this. Yeah, there is a video, but I actually didn't even bother to go through that. But we'll continue. So, task 1, introduction, LAN topologies, local area network, LAN topologies. Over the years, there has been experimentation and implementation of various network designs. In reference to networking, when we refer to the term topology, we are actually referring to the design or look of the network and at hand. Let's discuss the advantages and disadvantages of these topologies below. Star topology. The main premise of star topology is that devices are individually connected via central networking devices such as a switch or a hub. This topology is the most commonly found today because of its reliability and scalability. Despite the cost, any information sent to a device in this topology is sent via the central devices to which it connects. Let's explore some of these advantages and disadvantages of this topology below. Because more cabling and the purchase of dedicated networking equipment is required for this topology, it is more expensive than any other topologies. However, despite the added cost, this does not provide some significant advantage. For example, this topology is much more scalable in nature, which means that it is very easy to add more devices as the demand for network increases. Unfortunately, the more the network scales, the more maintenance is required to keep the network functional. This increased dependence on maintenance can also make troubleshooting faults much harder. Furthermore, the star topology is still prone to failure, albeit reduced. For example, if centralized hardware that connects devices fails, these devices will no longer be able to send or receive data. Thankfully, these centralized hardware devices are often robust. Bus topology. This type of connection relies upon single connection which is known as backbone cable. This type of topology is similar to the leaf off of a tree in the sense that devices' leaves stem from where the branches are on this cable. Because all data destined for each device travels along the same cable, it is very quickly prone to becoming slow and bottlenecked. Devices with the topology are simultaneously requesting data. This bottleneck also results in very difficult troubleshooting because it quickly becomes difficult to identify which device is experiencing issues with data all traveling along the same route. However, with this said, bus topologies are sorry about that. My alarm rang. Continuing now. Bus topologies are one of the easier and most cost-effective topologies to set up because of their expenses, such as cabling or dedicated networking equipment used to connect these devices. Lastly, another disadvantage of this topology is that there is little redundancy in place in case of failures. This disadvantage is because there is a single point of failure along the backbone cable. If this cable were to break, devices can no longer receive or transmit data along the bus. Ring topology. Ring topology, also known as token topology, boasts some similarities. Devices such as computers are connected directly to each other to form a loop, meaning there is little cabling required and less dependence on dedicated hardware such as within a star topology. A ring topology works by sending data across the loop until it reaches the destined device, using other devices along the loop to forward the data. Interestingly, a device will only send receive data from another device in this topology. If it does not have any to send itself, if the device happens to have data to send, it will send its own data first before sending data from another device. Because there is only one direction for data to travel across this topology, it is fairly easy to troubleshoot any faults that arise. However, this is a double-edged sword because it isn't an efficient way of data traveling across network, as it may have to visit many multiple devices first before reaching the intended device. Lastly, ring topologies are less prone to bottleneck, such as within bus topology, as large amounts of traffic are not traveling across the network at any one time. The design of this topology does, however, mean that a fault such as a cut cable or broken device will result in the entire network breaking. And here you have a picture of what the topology that we are just speaking of, which is the ring topology. What is a switch? Just before we start, I just want to show you a quick picture of what a switch is, how it looks like. So you have the internet here, the router, and the router is going to two switches, and right here it has those two switches are connected to those computer monitors. What is a switch? Switches are dedicated devices within a network that are designed to aggregate multiple other devices such as computers, printers, or any other networking capable devices using Ethernet. These various devices plug into a switch port. Switches are usually found in larger networks such as businesses, schools, or similar sized networks, where there are many devices to connect to the network. Switches can connect a large number of devices by having port of 4, 8, 16, 24, 32, and 64 devices to plug into. Switches are much more efficient than their lesser counterparts, hubs, repeaters. Switches keep track of what device is connected to which port. This way, when they receive a packet, instead of repeating that packet to every port like a hub would do, it just sends it to the intended target, thus reducing the network traffic. Both switches and routers can be connected to one another. The availability to do this increases the redundancy, the reliability of a network by adding multiple paths for the data to take. If one path goes down, another can be used. While this may reduce the overall performance of a network because packets have to take longer to travel, there is no downtime, a small price to pay considering the alternative. What is a router? It's a router's job to connect networks and pass data between them. It does this by using a routine, hence the name router. Routing is the label given to the process of data traveling across networks. Routing involves creating a path between networks so that this data can be successfully delivered. Routing is useful when devices are connected by many paths, such as in the example diagram below. And that is what it's referring to right here. So practical. Attached to this task is an interactive practical feature featuring the discussing LAN topologies. Learn about the various ways in which they are vulnerable to breaking. Break the LAN topologies to retrieve the flag. So we will do this on the last task actually. So now moving on to answer the question below. First, what does LAN stand for? And that stands for local area network. Second question, what is the verb given to the job that routers perform? That is routing. Third, what device is used to centrally connect multiple devices on the local network and transmit data to the correct location. That's a switch. What topology is cost efficient to set up? That is a bus topology. Next one is what topology is expensive to set up and maintain? And that is a star topology. Next one is complete the interactive lab attached to this task. What is the flag given at the end? So let's get started. Let's view the site. Topology flaws. This lab will take you through the flaws in different network topologies. Ring topology. In a ring topology, all devices are connected to two other to create a full circle. Ring topology. Packets of data travel from one device to the next until they have reached their destination. Ring topology. One of the major flaws with a ring topology is that if a device goes down or a cable is broken, the data will no longer be passed. If you hover over the middle of the network cable, you can cut it and see what happens to the packet. So let's go ahead and cut this. And as you can see, it stopped sending the messages. Moving on to bus topology. With a bus topology, all the devices are connected to a single cable, often called a backbone. Data is sent in both left and right directions down the backbone until the packet's destination is reached. A major flaw in the bus topology is that it can't handle a large amount of data. On the next step, send as many packets as quickly as you can try and take down the network. So now we have to overwhelm it. The bus network is down now. So we definitely overwhelmed it to where the bus topology network went down. Moving on. Star topology. With a star topology, all devices are connected with their own cable to a central switch hub, as you can see right here. Star topologies, every packet is sent through this switch, which means if the switch goes down, the network will no longer work. See if you can somehow break the switch. So we'll take our hammer out and we're gonna break it. And now it is done. And the star topology is now down. Voila. And here you go, just copy paste that. And you put this on the down on the answer box, and you are set to go to the next chapter. Moving on to task 2, a primer on subnetting. As we previously discussed throughout the modules so far, networks can be found in all shapes and sizes, ranging from small to large. Subnetting is the term given to splitting up a network into a smaller miniature networks within itself. Think of it as slicing up a cake for your friends. There's only a certain amount of cake to go around, but everybody wants a piece. Subnetting is you deciding who gets what slice and reserving such a slice of this metaphorical cake. Take a business for example. You will have different departments such as accounting, finance, human resources. Now I'm going to go over this picture. So you have this at the top, you have the internet at the top, you have the router, and you have the switch. And the switch is going to accounting, and it's also going to human resources and the finance department. While you know where to send information in real life to correct departments, networks need to know as well. Networking administrators use subnetting to categorize and assign specific parts of a network to reflect this. Subnetting is achieved by splitting up the number of hosts that can fit within the network, represented by a number called a subnet mask. Let's refer back to our diagram from the first room in this module. As we can recall, an IP address is made up of four sections called octets. The same goes for a subnet mask, which is also represented as a number of 4 bytes, 32 bits ranging from 0 to 225. Subnets use an IP address in 3 different ways. Identify the network address, also identify the host address, and identify the default gateway. Let's split these 3 up to understand their purposes in the table below. So for under type, we have the first one, which is network address. The purpose for this is this address identifies the set start of the actual network and is used to identify a network's existence. The explanation. For example, a device with the IP address of 192.168.1.100 will be on the network identified by 192.168.1.68. Now I'm just gonna go through the type and the purpose. So moving on to the second one, host addresses. An IP address here is used to identify a device on a subnet. For example, a device will have the network address of 192.168.1.1. Default gateway. The default gateway address is a special address assigned to a device on a network that is capable of sending information to another network. Any data that needs to go to this device that isn't on the same network, isn't on 192.168.1.0, will be sent to this device. These devices can use any host addresses, but usually use either the first or last address in a network. Now, in a small network such as at home, you will be on a subnet, as there is an unlikely chance that you need more than 254 devices connected at one time. However, places such as businesses and offices will have much more of these devices: PCs, printers, cameras, and sensors. Where subnetting takes place, subnetting provides a range of benefits including efficiency, security, and full control. We'll come on to explore exactly how subnetting provides these benefits at a later date. However, for now, all we need to understand is the security element to it. Let's take the typical cafe on the street. This cafe will have 2 networks, one for employees, cash registers, and other devices for the facility, one for the general public to use as a hotspot. Subnetting allows you to separate these 2 use cases from each other while having the benefits of a connection to a larger network such as the internet. So moving on to answer the question below. What is the technical term for dividing a network up into smaller pieces? And that is subnetting. Second one, how many bits are in a subnet mask? That is 32. Moving on. What is the range of a section octet for a subnet mask? And that's 0 through 225. Next one. What address is used to identify the start of a network? That's network address. Moving on. What address is used to identify devices within a network? That's host address. For our final one, what is the name used to identify the device responsible for sending data to another network? That is the default gateway. And that concludes this part of this section. Now moving to task 3, ARP protocol. Recalling from our previous task, the previous devices can be two identifiers: a MAC address, an IP address, and the Address Resolution Protocol, or ARP for short, is the technology that is responsible for allowing devices to identify themselves on the network. Simply, the ARP protocol allows devices to associate its MAC address with an IP address on the network. Each device on the network will keep a log of the MAC address associated with other devices. When devices wish to communicate with another, they will send a broadcast to entire a network search engine. Searching for the specific device. Devices can use the ARP protocol to find the MAC address, and therefore the physical identifier of a device for communication. How does ARP work? Each device within a network has a ledger to store information, or which is called a cache. In context, the ARP protocol, this cache stores the identifiers of other devices on the network. In order to map these two identifiers together, IP addresses and MAC addresses, the ARP protocol sends two types of messages: ARP request and ARP reply. When an ARP request is sent, a message is broadcasted to every other device found on the network by the device asking whether or not the device MAC address matches the request IP address. If the device does have the request IP address, an ARP reply is returned to the initial device to acknowledge this. The initial device will now remember this and store it within its cache. An ARP entry. The process is illustrated in the diagram below. So you have your first step right here and your second step right here as shown. First message: who has the IP address 192.168.1.10? And then basically, second message is I have IP address 192.168.10. Moving on to answer the question below. What does ARP stand for? And that is Address Resolution Protocol. Second question: what category of ARP packet asks a device whether or not it has a specific IP address? And that is request. Third, what address is used as a physical identifier for a device on a network? And that is a MAC address. Fourth, what address is used as a logical identifier for a device on the network? And that is an IP address. And that concludes this section. Moving on to task 4, the DHCP protocol. IP addresses can be assigned either manually by entering them physically into a device or automatically, and most commonly by a DHCP, Dynamic Host Configuration Protocol server. When a device connects to a network, if it has not already been manually assigned an IP address, it sends out a request, DHCP discovery, to see if any DHCP servers are on the network. The DHCP server then replies back with an IP address that the device could use, DHCP offer. The device then sends a reply confirming it wants the offered IP address, the DHCP request, And then lastly, the DHCP server sends a reply acknowledging this has been completed, and the device can start using the IP address DHCP ACK. So now this picture is demonstrating what I just read to you. So you have the DHCP discover saying, "Hey, I'm new here. Is there anyone who can give me an IP address?" This first computer right here. Then this goes to the DHCP, which then says, "Hey, sure thing. You can have 192.168.1.10 IP address." Thirdly, the DHC requests, "Yes, that would be brilliant. I'll start using the IP address," the computer says to the DHCP. DHCP8, "Okay, great. You can use the IP address for the next 24 hours." So, moving on to answer the question below. What type of DHC packet is used by a device to retrieve an IP address? And that is a DHCP discover. Moving on. What type of DHC packet does a device send once it has been offered an IP address by the DHCP server? And that is a DHCP request. Moving on. Finally, what is a DHCP packet that is sent to a device from a DHCP server? And that is a DHCP ACK. And that concludes this section, guys.